Now here is something very interesting which is going to happen. The lower transistors all are off 65, 66 and bit lower has gone to 0, which will not affect C cell 65 or C cell 66 in any way because there is no connection. However, when bit line upper has gone to VDD, remember that W line 2 to W line 63 or rather 64 all are still off. So again this VDD is not going to affect C cell 2 or till C cell 64 any cells. However, word line 1 is still high. That means this VDD now and this C cell 1 had actually gone down by VDD. That means it has lost its value. We were reading a 1, right? But due to charge sharing, it had gone down lesser than VDD, so it was losing its value. Now because bit upper has become VDD, it will write this VDD back into C cell 1 because this is nothing but still a closed circuit, or WL1 is still equal to 1. So I retained my value during this read. So sense amplifier did not only amplify the small difference in my bit upper and bit lower, but also ensured that the C cell value which had got deteriorated or degraded to restore to its original value. So this was quite interesting, isn't it? Similar thing we can explain for reading a 0 as well. Now the question here is, how do we refresh the circuitry for read? Let's go ahead and see this on the second slide. We just saw that C cell 1 was equal to 1, and in that same example we have taken C cell 2 equal to 0, C cell 65 equal to 1 and C cell 66 equal to 0. Now let's still understand the same case. We all understand that WL1 was 1. That means this transistor was on. But let's see a very interesting thing. See, C cell 65 is also 1. Let's focus on this transistor. Right now WL65 is 0. So technically this transistor is off and C cell 65 should be able to hold its value to 1. Does that happen? It does not. Because when this transistor is off, or for that matter any transistor is off, the capacitor tends to start losing its value due to a problem called as charge leakage. And hence it can very well happen that if we keep this transistor off for a longer period of time, that is beyond the whole time, it might lose out on its value. So how do we ensure that we don't lose out on this value which is already being written on C cell 65? We have to ideally read each cell in each row. What do I mean? Let me explain that. What you need to do is, say after word line 1 was being made high, then you make your word line 2 high, and when you make your word line 2 high, you will read what is present on C cell 2, and we saw that while reading we are also able to rewrite the same value because of the sense amplifier working. Similarly for C cell 65, if C cell 65 becomes 1, that means this turns on and there will be a difference on bit lower and the voltage across the capacitor. This difference would be amplified by the sense amplifier, and then bit lower will again rewrite the same value which it was holding. Did you understand? What reading operation is doing is, it's not only amplifying the small difference, but it's also ensuring that it is rewriting the same value which was degraded back into the cell. So we need to periodically read each cell in a column or the entire array. Now comes a very important thing about column select. Let's quickly understand this. This is very straightforward. So this is just one column. Like this, the same circuit can be present in the second column, the same circuit can be present in the third column, fourth column, and we can have an array. So how do we ensure that this column is selected? For that, we have a column select signal. It's a very simple circuit, don't get confused. Column select signal is again nothing but a pass transistor, which is one leg connected to X and the other leg connected to the column select signal or through a line which goes in all the columns. So here for the second column, similar circuit would be present. With its sense amplifiers X, a pass transistor would be connected.